Here in session 73, we're now going to address the algebraic fractions. Quickly, the main difference between a normal fraction and an algebraic fraction is that in an algebraic fraction you have a variable somewhere in the fraction, whether it's in the numerator or the denominator or both. So here are four examples of some algebraic fractions. First one is x over 6. There's our variable x in the numerator. Therefore, we have an algebraic fraction. Our second fraction, x plus 7 over 11. That's also an algebraic fraction. There's our variable x in our numerator. Our third fraction, 5x over x minus 2. That's an algebraic fraction. We have a variable in both our numerator and our denominator. In our last fraction here, 1 over x squared, we have a variable x squared in our denominator. These are all four types or four examples of an algebraic fraction. Let's rewrite our x over 6 fraction here. And what we want to do is to create another equivalent fraction to x over 6 by multiplying both the top and bottom by the same number. So what we're going to do here is say, let's take x over 6 and multiply it by 4 over 4. We're going to multiply the top by 4 and we're going to multiply the bottom by 4. If you take a quick look at 4 over 4, what is 4 over 4 the same thing as? Well, it's the same thing as 1, because any number divided by itself is 1. 4 divided by 4 is 1. Are we changing the value of x over 6 at all when we multiply it by a 1? No, because any number times 1 is itself. So we are actually just multiplying x over 6 by 1. We have just simply chosen to write 1 in the format as a fraction of 4 over 4. So this will give us an equivalent fraction. Now let's carry out the multiplication. X times 4 is 4x. That's our numerator. Our denominator would be 6 times 4, 24. So then, x over 6 is the same thing as, or it's equivalent to, 4x over 24. Let's take a look at another example here. We're going to rewrite 5x over x minus 2. And what we're going to do here is the same thing. We're going to create another equivalent fraction, and we're going to do it by multiplying both the top and the bottom by the same number. This time we're going to multiply by 3. So if we multiply the top by 3, we also have to multiply the bottom by 3. 3 over 3 is the same thing as 1. So by multiplying 5x over x minus 2 by 1, by 3 over 3, we have not changed the value of this. It will give us an equivalent fraction. 5x times 3 is 15. And then let's use our distributive property here. Let's take our 3 times the x, that'll be 3x. And then 3 times a minus 2 will be a minus 6. So then, 5x over x minus 2 is the same thing as 15 over 3x minus 6. Before we move on to the next screen, it's important to remember that the value for the denominator of a fraction can never equal 0. If we take a look here, x over 6, 6 is not 0, so that's legitimate. In our second one, x plus 7 over 11, 11's in our denominator, that's fine. But let's take a look at this third one, 5x over x minus 2. What value for x would we get, or which value for x would we have in order for the denominator to be 0? In other words, what number, x, minus 2 equals 0? Well, x would have to equal 2. So if x equals 2, we now have a fraction in which we have 0 in our denominator, and we are not allowed to have that. That does not exist. So for this particular fraction here, 5x over x minus 2, it's always understood that the denominator can never equal 0. So in order for that to happen, x can never equal 2. Because if x did equal 2, we would have 0 in our denominator. And lastly here, 1 over x squared. X cannot equal 0 because x squared would be 0, and we are not allowed to have a denominator of 0. Okay, moving on here. On our first screen, we created equivalent algebraic fractions by multiplying both the top and bottom by the same number. Here, we're going to do the same thing. We're going to create equivalent algebraic fractions, but this time we're going to do it by dividing the top and bottom by the same number. And as you remember, when we reduce fractions, we are actually dividing the top and bottom by the same number. So here's our question. Take the fraction x squared minus 9 over x plus 3, and let's reduce that to a fraction in lowest terms. Well, at first sight here, it doesn't necessarily look like we have an easy answer here. How are we going to reduce this? What's the common factor that we can divide both top and bottom by? Well, if we look at our numerator here and we remember back to some of our factoring strategies, we should recognize something here about our numerator. First of all is our first term, x squared. Is that a square of something? Yeah, it's the square of x. Take a look at our second term, 9. Is 9 the square of something? Yes, it is. It's the square of 3. So what we actually have here is we have the difference of two squares. Now then, we can go ahead and factor the top based upon the fact of factoring the difference of two squares. And what that'll do is it'll give us x plus 3 on top times x minus 3, because remember that's how you factor the difference of two squares, over x plus 3. Now, we have two terms being multiplied by each other in the top, and we have a term on the bottom, a polynomial. We can actually take the x plus the 3 now, since this entire term here is being multiplied by everything else up top. We can actually cancel those two x plus 3's. What's that then leave us with? Our x minus 3. So I'm just going to go ahead and rewrite that over here at the right as x minus 3. So then, the fraction x squared minus 9 over x plus 3 reduces to x minus 3. Or, if you want to see that 1 in the denominator, because remember, x plus 3 in the denominator is really being multiplied by 1. So when we cancel that x plus 3, it doesn't leave us 0 in the denominator. All it leaves us is the 1 that x plus 3 was being multiplied by. But x minus 3 over 1 is the same thing as x minus 3. Both of those are correct. Next, let's say we were wanting to create an addition or a subtraction problem here. I'm not going to actually carry out the actual adding or the subtracting, but in order to add or subtract fractions, what do you have to have in the denominator? What relationship do you have to have? Well, you have to have the same denominator. So in order to add 7 over x to x over 11, or in order to subtract x over 11 from 7 over x, we have to have the same denominator. So what we need to do then is to create equivalent fractions to both of these such that they have the same denominator. Well, if you remember, we can always get a common denominator by taking the denominator of our second and multiplying our first fraction by that denominator over itself. So what we would do then is we would take our 7 over x and we would multiply it by 11 over 11. Multiplying the top number by 11 and dividing the bottom number by 11 is the same thing as multiplying by 11 over 11. Well, what is 11 over 11? It's the same thing as 1. So once again, we are taking our fraction 7 over x and we're really just multiplying it by 1. And when you multiply by 1, you are not changing the value of it. But by rewriting 1 as 11 over 11, it will help us to get the denominator that we're after. Let's quickly multiply it out. What is 11 times 7? Well, that's 77. Then in our denominator, 11 times x is simply 11x. 7 over x is the same thing as 77 over 11x. Let's come to our second fraction here. What we're going to do is multiply the top and bottom by our denominator of the first one. So what we're going to actually be doing is multiplying by x over x, which is just 1. So now let's multiply these two fractions together. X times x is x squared, and 11 times x is 11x. So we can see that x over 11 is the same thing as x squared over 11x. We now have both of our fractions as equivalent fractions with our common denominator now of 11x. Quickly as a review, algebraic fractions have the same properties that arithmetic fractions do. The main difference between the two being that algebraic fractions have one or more variables in the numerator and or the denominator. And lastly, the denominator for a fraction can never be 0. That'll finish up session 73.